Hey there, Seth Mayo here, Curator of Astronomy for the Lohmann Planetarium here at MOAS. And for this video, I want to talk about the International Space Station, or the ISS, that orbiting laboratory more than 250 miles above our heads, circling the Earth every 90 minutes. So I want to talk about this amazing piece of technology where astronauts live inside of it, doing cool science and experiments and perfecting technology in low Earth orbit. So I'm going to show you the ISS with some of our planetarium software. We're going to fly around it, a 3D model of the ISS, talk about that. And then I'm going to do a VR or virtual reality tour. I'm going to put a headset on and show you what the space station looks like from inside. We'll kind of walk through, or really float through the ISS together and look at this amazing 3D model of the space station that we can tour through. The reason why I want to do this video about the ISS is to celebrate this very important mission that is happening at the end of this month. Hopefully on May 27th, we have SpaceX launching their Crew Dragon capsule on their Falcon 9 rocket. This is called Demo 2 mission. And they're launching astronauts Bob Behnken and Doug Hurley. This is the first time we've launched people from American soil since 2011, when the space shuttle Atlantis had its last flight into space. And this is the first commercial crew launch ever in history. So it's a really big deal. A lot of milestones are being met. So let's celebrate that and the ISS. So come on with me as we digitally launch to the space station. Here we go.
All right, welcome to space. We made it. And right now we're using our Lohmann Planetarium software we call UniView to navigate the universe anywhere we like in a three-dimensional environment. Of course, we're now looking at our beautiful planet Earth. Now, if you look closely, you'll see that I've turned on this purple orbit around our planet, and that is the orbit of the International Space Station, or the ISS. And kind of a fun piece of trivia that our own executive director of MOAS, Andrew Sandall, brought up in a Facebook social media post recently. And the question is, when was the last time that every human being alive was actually on the Earth? And the last time that happened was in the year 2000, because in late 2000, the first crew was sent to the ISS. And since then, we've had a continuous presence in space all the way up until now, here in the year 2020. It's amazing. That has never faltered since then. And so another kind of fun fact is that if you were born after November of 2000, you've never known a time when there was no one in space. You've always known that there is someone in space, and that's kind of a common thing, right? So it really shows us here in the 21st century that we are truly a spacefaring world, and that's continuing to be more of a reality as time goes on, right? So it's an exciting time for space exploration. And to talk about space exploration, let's fly to the International Space Station. Here we go. And the ISS is traveling at more than 17,000 miles per hour. It only takes 90 minutes to go around the Earth once. So if you're on the station, you'd have about 16 sunrises and sunsets every day. Imagine that view, right? And the station is about 250 or so miles above our heads, which actually doesn't seem like that high up, right? And that's why this is in low Earth orbit, but high enough to be in a near vacuum or pretty close to a vacuum, not perfectly so though. And so now we're looking at the entire station. Now, to give you kind of an idea of size here, if you measure the entire area of the station with the panels here, it's about the size of a football field. So it is really big. And the main part that really sticks out to you are these solar panels. These solar panels, or what we call solar arrays, absorb energy from the sun, convert the energy into electricity used aboard the station. And there's about 27,000 square foot of useful solar panel space. That's about an acre. And that's enough solar panels to power about 40 average-sized homes here on Earth. They need a lot of power to run all sorts of equipment on the space station, life support systems, and all that kind of cool stuff. Now that's the solar panels. They do look like wings. Of course, there's no air in space, so you don't need wings. There's no air to have lift. The station actually just falls around the Earth. And a common misconception about things in orbit is that there's no gravity. And there actually is. Actually, Earth is still pulling the station down. But the thing is, the station is in a forward movement that matches the Earth's rate of pulling it down. And that allows the station to basically miss the Earth every time it goes around the planet. It actually is just falling around, missing the Earth over and over again. And that's how basically the orbit works, right? Now, occasionally the station does sort of sink down in its orbit because there's a little bit of atmospheric drag, slows the station down. That's just a little bit. So every so often, the crew has to boost the station up. And the way they do that is they fire these little rockets that make the station go faster in its orbit, and that actually broadens or widens out the orbit. So they go a little bit higher in altitude above Earth's surface. So again, main features you really see from far away are those solar panels. They're quite large. They were brought up by the space shuttle over the years, and then they were folded up, and then they unfurled in space. And then we have this part here. We'll zoom in a little bit. It's basically the backbone of the station, and this is what's called the truss system. So everything kind of connects to the truss. And then here we have the modules. That's where people actually live. They almost look like big kind of tuna can shaped pieces. And so these modules were constructed together over space. So you can kind of think of the station as like a big erector set built in orbit. At least the pieces were put together in space, or a Lego set in space is kind of another fun way to think about it. Now, what's so exciting is this upcoming commercial crew mission. And this commercial crew mission is launched by SpaceX, and it's the first commercial crew flight ever in history. It's supposed to go on Wednesday, May 27th. We'll see. Hopefully the weather works out and there's no other mechanical or systems issues that will arise. And this has been a long time coming, right? So the last time Americans launched from American soil was the last shuttle flight, the last space station construction mission, and that was from Space Shuttle Atlantis back in 2011. That was in the summer of 2011. So it's been close to a decade since then. We'll just jump to a 3D model of the space shuttle. It's kind of fun. This is actually a model of Atlantis. Now sits at the Kennedy Space Center Visitor Complex in a really cool gallery. And so a lot of the modules, the pieces of the space station were brought in the cargo bay. So 2011 was the last flight. And what's so cool is one of the pilots on this shuttle was Doug Hurley, who will be flying aboard the Crew Dragon on the 27th. So he was one of the last Americans to fly from the Kennedy Space Center, and now the first to fly since then. And so it's kind of neat. It's kind of brought it full circle. So anyway, we'll head back to the ISS here. And so we have the commercial crew mission. This is called the Demo 2 mission from SpaceX. And as all of you probably know, or at least most of you know, SpaceX is quite an amazing space company, private organization that builds their own rockets and capsules. And their rockets not only launch, but their first stage is also land back on Earth. It's quite amazing. And since 2012, I'll show you a picture here. SpaceX has launched these kind of cargo missions here. So this is actually what's called the Dragon. And this was actually the first time SpaceX got their capsule to connect with the ISS and then dock with it. So this is back in 2012. And so there's the Dragon with some solar panels there. And this is the Canadarm, one of the robotic arms on the station. They grapple or connect with the Dragon, and then they bring it up to this sort of mating dock here. All right, that's a docking port, and that's how you would connect it to the station. Now, the first time that ever happened was in 2012, and since then, SpaceX has been launching all of these commercial kind of resupply missions to the ISS, and it's been quite successful ever since. So what's now finally happening is this crew mission, because NASA is trying to look more towards deep space with their own launches, their own crewed launches, going back to the moon, possibly to Mars one day. So they had commercial companies sort of vie or compete for access to the space station to low Earth orbit to launch their astronauts into space. So finally, SpaceX is now the first to do so. And we have now the first 2 astronauts to do this, kind of a demo test flight. On the left here, this is astronaut Bob Behnken. On the right is Doug Hurley. I talked about him just a bit ago. He was on Space Shuttle Atlantis in 2011, now flying again on the Crew Dragon. These are both very experienced astronauts. They both have gone to space twice themselves and have a lot of experience. And so they are a very experienced crew, and they're best friends, which helps as well. And they're wearing these really cool futuristic spacesuits. So this is kind of the new design, very much in line with kind of modern day sort of, of what we think of spacesuits and space exploration, right? And so that's kind of a neat way to travel in a very modern spacecraft. It's a capsule design, just like the Apollo days. It is reusable, and they're using touchscreen computers. So they're using actually what we now use today on like iPads and and on touchscreen computers and our phones. They're using that as their primary instrument panel, and again, very 21st century. And so they're launching on a Falcon 9 rocket. I'll show you that. This picture will come up in a second. There you go. This is actually a picture taken recently when the rocket, the Falcon 9 here, and it's mated to the Crew Dragon that the astronauts will sit in. This was the rollout. So this is when the whole rocket and the Crew Dragon were rolled out to the launch pad at Kennedy Space Center at pad 39A. And that's the launch pad that launched the shuttle many times. And even going back to the Apollo days, launched the Saturn V to the moon. Very historic launch pad. And SpaceX has been leasing that pad and building their own launch pad with a really cool gantry way that's futuristic looking. And they're using that to launch this first crew mission coming up soon. So we'll see if that goes to plan or that works successfully. And I'm sure it will, but keep fingers crossed for a successful mission there. So where they're docking, just to show you kind of on the station what we're looking at here, they're docking, I believe, on the underside of the forward section of the station called Node 2. And that's the Harmony module. So if you look underneath, so this is actually the front side, just to give you an idea of the sides of this. This is called the forward section. This is the aft section, the back side. So the station actually moves in this direction here. So it kind of moves like this through space. This would be the port side. So if you're on the station looking in this direction, this would be your left side. This side would be your starboard side, the right side. Up above you is the zenith side, up high. And then below towards the Earth is called the nadir side. So those are the directions that we're looking at here. So on the forward side here, let's see, we're going to kind of move ourselves a little closer. There are some docking ports. The space shuttle docked here, and then I believe SpaceX Crew Dragon will dock underneath here, if I'm not mistaken, right there. And once they do, they'll dock, and then the crew will go inside. And these are all the modules that astronauts live in, and they're built from countries around the world. If you look at some different flags here, this is the Japanese called the GEM or the Kaibo module. GEM stands for Japanese Experiment Module. And so that's a pretty big module there of different science experiments. They have an exposed laboratory here. So they put things out into space here. And there's a Japanese robotic arm right there. On this side here, you'll see ESA. That's European Space Administration. This is called the Columbus module, another laboratory. It has American, European science experiments on there. We'll actually turn ourselves to look underneath here. This again that you see here is Node 2, and it has connection ports, docking ports underneath. Right here is called the Destiny Laboratory. So this is an American laboratory there with a ton of experiments. They control the robotic arm from there. And if we look on this side here, we'll kind of zoom out just to kind of show this to you as best I can. Okay. So right here, this is called Node 1. This is the Unity module. It's one of the first American components put into space on the ISS. This is the Quest airlock right here. So that is where the spacesuits are stored. And then this is where the astronauts will go in their suits, they'll depressurize, and then they can leave and do a spacewalk and do any kind of repair or any type of work outside. They leave this section here. Let's see here. And then we move to this side here. That's node 3. There are some bathrooms in there. And then you have here the cupola. That's like a big window in space looking down the nadir side, or the Earth-facing side of it. It's kind of like a moon roof or a sunroof, except it's an Earth roof instead, because you're seeing Earth in its view. That's a cool way to think about it. So these are windows. This is an Italian-built window or compartment. Again, it's called the cupola. It's an Italian word, right? And so that's a neat little area there. And if we actually zoomed out here to the aft section, because again, we're kind of underneath the station, right here, this is the back side. These are all like Russian segments. You have the Zvezda, which is the first segment put into space for the ISS. This is the Zarya. And they use Zvezda as a boosting spacecraft that can push the spacecraft or the ISS forward faster to boost its orbit. And sometimes you'll get Soyuz Russian capsules that bring up astronauts and cosmonauts, and also Progress capsules here. The Progress are the Russian cargo capsules that are uncrewed. And then one last thing I'll show you before we actually head into the station. See these little funny little accordion shaped things here? Those are thermal radiators. So one really big problem on spacecraft are that the instruments, computers, various things like that generate a lot of heat, and it's hard to get rid of that heat, to dissipate that heat. There's no air out here, and air can carry heat away, right? That's called convection. We have that on Earth, right? Well, convection doesn't really happen in space, or at least something that you have. It's a problem to vent heat in space. So one way to do it is you use these radiators to kind of radiate heat outwards, try to get it away from the inside the station. So that's what these funny little shapes are here, right there. So that's kind of interesting. So anyway, now we've seen the outside of the station, and also talk a little bit about that commercial crew mission coming up here, which is quite exciting. We're going to now head inside of it. So I'm turning ourselves in just the right way. Let's see if I can orient ourselves. I feel like I'm a docking spacecraft here. And what we'll do is we'll just move ourselves just right. We'll look here, and there's the Quest airlock. So we'll head inside this part here in virtual reality, and we'll do a little walkthrough through the American side of the ISS. So here we go. All right, so now we are in virtual reality mode, and I am now looking at the International Space Station. This is a pretty accurate 3D representation of the ISS, and I'll try to move as smoothly, as slowly as I can, so it's not too jerky on the screen. But where we left off in that 3D view on UniView, now I'm kind of there myself, and this is a really cool way to experience this. And actually, virtual reality is used quite a bit by NASA and other space companies to train the astronauts, train the crew, and the engineers as well that work on it. You can use virtual reality. So this is a very effective way, not only to teach and to show people things, but to experience and to train for what these astronauts are going to have to go through soon. So anyway, we are now looking around here, and as we do, I'm kind of facing towards the aft sort of side here. So if you look, and I'm going to use a pointer at different times. So I'll use this pointer right here, almost like a lightsaber here. There you go. I almost want to make lightsaber sounds. All right, I'll spare you from that. But if you look here, there's the Russian side there. And actually, if you look down there in orbit in this 3D model, they actually did put the Dragon capsule, just the cargo capsule there. So that's kind of neat that they put that in this. If I turn around, and actually I can just sort of turn myself with my joystick. Whoa, there we go. Now we're looking at the big solar arrays. Remember how large I said they were? So this will kind of give you a feeling. If you could stand on them and look out here, if you could stand and look how large these are. Again, all together 27,000 square feet, about an acre of usable solar arrays to capture energy from that sun and to power the station. We can actually walk along it a little bit and take a look here from kind of a more farther out view. Let's go all the way down here. It's kind of fun to see it from afar. Earth moves pretty quickly here. There you go. I don't know if that's the exact rate, but it's pretty fast. Again, moving at 17,000 miles per hour is no small speed, right? So anyway, here we go. Now we have a nice overall view of the station. There are those thermal radiators, that accordion-shaped piece there. Technically, this is the aft section, and that's the forward section. This would be the zenith section up here, and then down there is the zenith. This would be the starboard side and port side there. So I think they have this situated kind of differently, but that's okay how it's moving around the planet, but that is fine. And so let's take a look here at a couple things. So we're going to just move over closer to the truss. Remember I told you the big backbone of the station? There it is, the truss element there. Okay, but we'll continue moving in this direction. There we go, and I'll turn ourselves. I don't think I need this anymore for now. You can see a couple simulated astronauts doing spacewalks right there in front of me. Okay, so let's move on towards the Destiny, or actually the Quest airlock. I'll show you a couple of things. Let me bring back my pointer again, my lightsaber. And hey, got Hawaii underneath us right now. That's fun. Okay, anyway. So actually, that's the Destiny laboratory there. All right. There's the Columbus module. This is the Quest airlock right here that we're looking towards. Okay. Oh, and there's that's the Canada arm right there, built by Canada, of course. And so let's go into the airlock. So we'll get a little closer, and just like an astronaut would, we would kind of be floating around here, if you can see me. And then eventually I would, you'd hold on to those hand railings and pull yourself in, right? So let's try it out and see what happens. And whoa, we're making our way in. The doors are already open for us. That works pretty well. Let's see if I can get inside here. See if I can do it nicely. All right, I'm still getting the hang of this. Oh, we're a little bit high, so let me just get a little bit lower here. There we go. So hey, there's a spacesuit there. So this is that Quest airlock. I'll get kind of closer to the spacesuit, and we'll turn, and hey there, buddy. All right, so we can take a look there. All right, so you can see this is where actually normally these suits would be stored, or stowed as they like to say, and there would be much more equipment and suits in here. This 3D model is a very cleaned out, very simplified view of the interior of the space station. But that's okay. It gives us a pretty good overall understanding of what it's like to be inside as we look around. So, and a lot of the instrument panels are actually correct from what I've seen from different ISS videos and pictures. So again, if I turn ourselves this way and look here, there's the airlock that we just came through. Okay, and they just depressurize in here before they go out. And we'll come and walk this way. Actually, what we'll do is we'll go to the forward section of the space station. Okay, so let's see if we can kind of maneuver there. We'll tour back through here again, but we'll start in the forward section, or what's called Node 2. So here it is. Here is Node 2, and the very front of the station. And this is where all those docking ports are. So again, if I take out my pointer here, that's where the space shuttle would have connected to in the past. Down below, I believe, again, that's where the SpaceX Crew Dragon, at least where all the cargo, SpaceX cargo resupply missions were docking there. So I believe the crew will be also coming through that section on Node 2. Again, this is called the Harmony node, okay? And then we have, if you look on this side, this would be the starboard side. And then there's the port side of the station, since we're looking forward right now. Okay, so how about we'll just quickly go to the starboard side. And let's see here, I'm gonna kind of duck under here. There we go. And now we're looking at the Columbus module. So this is where we have all these different experiments and various pieces of equipment that are used. And a lot of times you're going to find microscopes and different chambers for different types of experiments, different racks where they can plug things in, and all sorts of equipment for various experiments. They usually have a couple hundred experiments going on the station on any given time. So this kind of shows you some of at least the pictures of some of those panels there. Okay, let's go this way here. And let's head over to the Japanese gem, or the Kaibo module. That's what we see right in here. You can see the Japanese flag there. Let's kind of duck in here, make our way in. Of course, again, we'd be flying around, ducking around things, and there'd be much more equipment all over the place. But again, it kind of gives us a neat view of these modules. All right. So I'm going to turn ourselves. So I'm kind of towards the camera again. And I do know, I think these circular cylindrical things here, they use these to heat things up, I believe. Sometimes they have chambers for fire or even for cooling. Actually, take that back. These are actually cooling, like for refrigeration. I believe these go down to like negative 80 degrees to cool various things. But they can burn things. They can grow things. Again, the experiments sort of run the gamut of subjects and topics and different disciplines, right? They do astrobiology, astronomy, engineering, all sorts of things you can think of that are done on the station in microgravity, in this sort of space environment. Okay? All right. So we can kind of look around some other equipment, other various things. If we zoom in again, this is the Kaibo module, Japanese size. It was Japanese experiments. Again, some experiments from other countries as well. And if we could, we can't actually look out this, but I think that's an airlock. You can go out and there's the exposed facility. So if we could look through those windows, which I don't think we can, you would see the exposed area where they put experiments to be exposed to the outside of space, basically. Okay. There you can see the Japanese flag there. All right, let's turn ourselves this way. And let's move more aft into the station. Again, we're staying on the American side. This won't let us go to the Russian segment. And hey, there you go. So you got labels here too. That makes it kind of easy. Port side there, deck to the lab. So there's the Destiny lab. All right. And hey, this is kind of neat. This is some exercise equipment. And I know the astronauts need to exercise at least 2 hours every day to maintain bone and muscle strength, right? They'll lose some of their calcium in their bones. They'll lose a little bit of muscle while they're up there. So to prevent that and to limit that as much as possible, they do a lot of exercising. Cycling machines, they have a treadmill. They have weightlifting types things where they do kinds of resistance training with a vacuum. Actually, instead of using regular weights, because that's not going to work, right? You can't use weights up here. Everything's weightless since you're falling around the Earth. You use sort of resistance type trainings, and I know they have equipment with vacuum tubes that like use vacuum pressure and stuff, or use vacuums to make resistance on the machine, basically. So that's kind of neat. Let's see, a couple other things I can look at here. Oh yeah, so I know these computers, at least these here, on my right side, these are controls for the Canada arm. So you can see one of the little joysticks right there. I don't know how close I can go to this. So it's a very simplified view of it, but that's a joystick, a laptop computer, and then monitors, cameras that are on the outside of the station, so they can use that robotic arm, control it. There's actually usually a joystick here, and then there'd be another one somewhere around here where my other hand is. And they would control the arm and, grapple onto equipment or the spacecraft, the cargo spacecraft, and then possibly I think the Crew Dragon as well could be attached to that too. And then on the other side, if I turn around, or I can just spin ourselves with my joystick. This is a trainer, so I know they use this to train for the Canada arm, and they do that before they actually have to use the real thing. So you can see those computers. So it's kind of neat that they included these in the 3D model. All right, so we're heading back this way here. Again, port side here, starboard side there. It says to node 1. See where my lightsaber pointer is? Node 1 right there. So that's where we're heading to now. Node 1 is a pretty early American side of it. And there we go. So I do know the astronauts will eat in this area here. So normally they have different places where they can get their food, they can warm up their food, they can hydrate it, they put water in it. And so that's where you find that. And let's see, we did come from that section there. If I can kind of walk this way. So that is the Quest airlock. There's the suits, and that's where we came through. And then in here is node 3. It's called the Tranquility module. Okay, and in node 3 has a couple interesting things here. There's the treadmill. So the astronauts, if you can see, again, this is a very simplified view, but see this sort of bar here? And I know they have equipment or a strap that they put on their shoulders or on their waist, and it pulls them down towards the treadmill. So they have some resistance, like they're being pulled down by Earth's gravity. It's a little different, and it does give them some feeling of being pushed down. And so this is the treadmill here that it's moving, and they run on it, and I hear it's pretty good. And then look at this. See this little moon shape there? What does that look like? Looks like the outside of an outhouse, right? Well, this is the station outhouse or the toilet. That's always a fun thing to talk about, right? You can even see in the label there's like an outhouse picture there. So there's the toilets, actually kind of what it looks like. And this is sort of this metal cylinder here. That's where solid waste goes in. And I'm sure you know what I mean by solid waste, the poop. Goes in here. They sit down. There's a vacuum chamber that sucks like a lot of the smelly air into there, and they put stuff in there and they replace these out, and then they actually throw them away. These bits are put into a cargo craft that gets burned up into the atmosphere actually. So they burn up their poop in the atmosphere. That's fun to think about, right? Okay, anyway, see this tube here? That is for urine. So it's a vacuum tube that they pull their urine out. And the urine and like their sweat and moisture actually is all recycled back in to their drinking water, which sounds really gross, but it's very efficient. And actually their drinking water, turns out, is cleaner than most people's tap water at home. That's really cool. So it's a very good recycling system. They reuse their fluids as best they can because they don't have all the equipment, all the supplies on the station. They have limited supplies. So as much as that you can recycle as possible, that's great. And then water, you can get air from water, right? Water is H2O. There's oxygen in water. So you can take the oxygen and make air out of it, right? So that's kind of a neat feature too. All right. So again, still in the Node 3 Tranquility module. All right, and if we look down, one of, I think, the coolest places on the station is down here. So there is the cupola. Remember that window, that Italian-made window in space? There it is. So let's head down there and see. We'll make a step down, and then one more step down here. Now, it might be hard, so I might have to crouch down. So this might look a little funny here. Let me turn ourselves. So I'm back towards the camera again. And there's the window, and that's kind of crouched down. Hey, there you go. There is Earth. So you can imagine how interesting and amazing this view would be for the astronauts, where they can look through here. They can actually control the robotic arm from here too, because they have a really nice window to look through. There is the Dragon capsule, again, the cargo capsule there. So this would be kind of a similar view to what the crew will see when the Crew Dragon on the 27th, or at least later that week, when it actually arrives to the station, gets there, and that will be the successful docking of the Crew Dragon, which will be really awesome. And then the crew, Bob Behnken and Doug Hurley, will probably spend some months actually on the station. Originally, they're just going to come back home and splash back down in the ocean on Earth. But now, since they don't want people to run out on the station, they don't want Americans to have no presence up here, they're going to leave them up here, I believe, for now. So that's kind of cool. So anyway, now that we're down in the cupola, let's head back up. Let's see if I can climb back out here. I can't really fly in this, so let's see if I can do this. Get out of here. There you go. Can kind of move out from it. And there we have it. So there is my tour through the station. Actually, let's head back outside. That's kind of a fun way to end this. And now we've been inside the International Space Station virtually. Hopefully you enjoyed that. Hopefully you could follow along. It wasn't too shaky or too fast here. But that was a lot of fun. And I can provide more tours like this in the future, or other things in space and virtual reality as well, if that's something that works nicely here. But anyway, probably should face the camera here. All right, there you go. Anyway, this is where I'll end this little video about the ISS, about the Crew Dragon, the Demo 2 mission coming up. Hopefully you enjoyed it. Thanks for tuning in to all this great content we've been putting out over this last couple months. We're going to continue to do so in the future. But take care. happy stargazing, happy space exploration, and all that great stuff. And signing off. Bye-bye.